Hello and welcome to my channel. In this video I will summarize the optics unit from grade 9 physics curriculum. Let's get started. We studied about two types of thin lenses, the converging lens and the diverging lens. And as their name indicates, the converging lens collects the parallel rays of light at one point, which is f prime, the image focus. Whereas the diverging lens separate the parallel light rays and they seem to come from one point, which is f prime. A converging lens is also called a thin edge lens or a convex lens, while the diverging lens is called a thick edge lens or a concave lens. Now let's move to the symbol of each lens. The converging lens has this symbol. This is the optical center O, and this is the image focus f prime and the object focus f. F and f prime are symmetric relative to O. In a converging lens, OF prime has the same direction as the direction of propagation of light. So if we put the source of light here, the direction of propagation of light is from left to right. And OF prime is also from left to right. So the focal length is positive, where the focal length is the distance between O and F prime. Now, in case of a diverging lens, OF prime is opposite in direction to the direction of propagation of light. The direction of propagation of light is drawn here from left to right, while OF prime is from right to left. So the focal length in a diverging lens is negative. Now let's see how special rays of light behave when passing through converging lens and diverging lens. Any ray that passes through the origin O continues without deviation. The second ray is the ray that passes through F. Any ray that passes through the object focus F continues parallel to the optical axis. And finally, any ray that is parallel to the optical axis emerges the lens passing through F prime. Now let's move to the diverging lens. The first ray is similar to that of a converging lens. Any ray of light that passes through O continues without deviation. Any ray of light that is parallel to the optical axis continues as if coming from F prime. Here we dotted because the ray of light doesn't go backwards. And finally, any ray of light that is directed towards F continues parallel to the optical axis. Remembering these special rays of light will help you to draw the image given by the lens. Now let's move to study the images given by the converging and diverging lenses. The image given by a converging lens can be real or virtual, can be erect or inverted relative to the object, can be magnified, diminished, or even equal to the object. That all depends on where you place the object on the optical axis. So, if you place the object at a distance greater than 2f, here for example, then you obtain a real image. A real image is an image that can be collected on a screen. The real image is always inverted with respect to the object. In this particular case, if d is greater than 2f, you obtain a diminished image. A diminished image means that it is smaller in size than the real object. A good example of this case is the lens of a camera. The second case is very important because it's the only case where you obtain the size of the image equals the size of the object. If you place the object at distance 2f, you obtain a real image which is inverted with respect to the object and equal to the size of the object. This is a very important case, and an example of this case is the case of photocopier. And the third case, if you place the object between f and 2f, here for example, so with a distance greater than the focal length but still less than 2f, then you obtain a real image which is also inverted with respect to the object, but in this case it is magnified. An example of this case is the case of LCD projector. Finally, a very important case when you place the object at distance less than the focal length. So here, for example, then the image will be virtual. And the virtual image is always erect relative to the object. In this case, it is magnified. An example of this case is the magnifier. Now let's move to the diverging lens. Unlike the converging lens, in the diverging lens we only have one case. So wherever you place your object on the optical axis, you will obtain the same characteristics. The nature of the image given by a diverging lens is always virtual. A virtual image is the image that can be only seen through the lens. It cannot be collected on a screen. You always draw a virtual image dotted. The virtual image is always erect relative to the object, that is, it is not inverted relative to the object. In case of a diverging lens, you always get a diminished image that is smaller than the object. As you noticed, in case of a diverging lens, you get a virtual image. And in case of a converging lens, you can also get a virtual image. However, the main difference between them is that the virtual image given by a diverging lens is diminished, smaller than the object. Whereas, if you get a virtual image by a converging lens, then it is magnified, bigger than the original object. Don't forget the scale. If you are not given a scale, or if you are given a real scale, then you need not to worry about this. But if you are given a scale, make sure to provide all your answers with the given scale. And of course, don't forget the units. You need 2 rays of light to draw the image of a given object. However, if you are provided with another given, a screen for example, or the position of the image, or the size of the image, then you need only 1 ray of light to draw the image. Light rays always have direction, so don't forget to put an arrow on each light ray you draw. If you have a real image, then you will see the things in this order. An object, then the converging lens, and then the real image. While, in case you have a virtual image, you will see them in a different order. You will see first the virtual image, and then the object, and finally the converging lens. In both cases, you might be given the object and the lens and you are asked to find the image. Or you might be given the object and the image and you are asked to locate the place of the lens. Or you can be given the lens and the image and you have to find the place of the object. So make sure to solve exercises about all these cases.